Okay, we're going to record on XSplit, and hopefully that'll work. All right, so today we're going to talk about the order of operations and exponents, and that will conclude. And then we're going to do a review for your big test, which I don't know when is going to be,
Okay.
but you're gonna have a test over.
Is this going to be a short lesson today?
Yeah, this is a short lesson. Well, it's one topic. It's not going to be. We're doing a full topic,
Okay.
so it's more than just a short lesson. Okay, so today we're only going to focus on, and we'll call this. We haven't even really started a topic yet, but today's focus: natural natural number exponents. What kind of numbers are natural numbers? What kind of numbers are natural numbers?
Positive numbers?
Yes, the numbers that come natural to you. So I'm just going to put the example of this set right here. So it's not going to be 0. I mean, you can use any number, any real number in an exponent. And we'll get to that later, but today we're just going to focus on natural number exponents. Okay, so just like multiplication is a shortcut for what?
Addition.
Repeated addition. The edge of the screen. Okay, addition. Similarly, exponents are shortcuts for guess. Guess what? Take a guess. It's repeated.
Uh, Wait, shortcuts for repeated multiplication?
Very good. Multiplication. Great guess. I don't think it was a guess, but we've only done 4 operations so far, so it's not addition. It's got to be repeated division. Doesn't make sense. Well, it can. It's kind of repeated division too. We'll get to that later, but it's repeated multiplication. So exponents are of the form. Uh, I'm going to use variables for this. X to the y, something like that, right?
Okay.
And x is called the base. Okay, in this case, it's what you are multiplying. Okay, so the base is what you are multiplying, and y is the exponent. What do you think that's going to be?
Mm, the number of times you multiply the
How many
number
times you
by?
multiply by itself? Very good. So x to the y is x times x times x times x y times. It's a fancier way to write it. Okay. Okay. This word is also could be powers. You'll see powers there too. Like 3 to the power 10 means 3 to the power 10. Okay. All right, so let's go over some uh, basic, not vocabulary, but ways to talk about exponents. Okay, so and we're going to use the easiest number to multiply by And it wouldn't make any sense to use 1, because 1 to the what, you're always going to get the same answer. Can't use
Yeah.
0, because 0 is not a well, yeah, you could use 0, but you'd still get 0. We're not going to do negative numbers yet, which we're coming. We're going to have negative bases. We're not going to have negative exponents. Okay. So that number I'm going to choose is 10. This is easy to multiply by 10. You just add zeros, right?
Mm-hmm.
Okay, so 10 to the 1 is 10. And that result is going to we say that 10 to the first.
Okay.
That's how it's read. Then the next one would be 10 squared, which would be 10 times 10, which is, my equal signs aren't going to line up. I apologize already in advance, but what's 10 times 10?
100.
100. This is read 10 to the second, but it's more commonly read as 10 squared, because to calculate the area of a square, right, this side would be 10 and this side would be 10, you multiply 10 times 10. So the common phrase is 10 squared.
Sick.
Yeah, pretty cool, huh? All right. 10 to the third power would be 10 times 10 times 10, which is
1,000.
1,000. Read as 10 to the third, or, these are my artistic skills for you, Keith. This is about the limit of it. What's that?
What? A
It's
cube?
it's a cube.
10 to the cubed.
Because if you want to find the volume of a cube, cubes all have the same size, you would multiply 10 times 10 times 10. So we would call this 10 cubed. Okay. We move it up. We're going to do one more. And you can guess which one it is. 10 to the 4th.
10 to the 4th.
Awesome. Yeah. Which is 10 times 10 times 10 times 10, which is 10,000, right?
Yeah.
Okay, 4th doesn't have a fancy one. 4th and higher, or any other exponent that is not 2 or 3, is just 10 to the whatever. 10 to the 4th. Okay. All right. Any questions over notation?
No.
Okay. Moving on. Any real number can be the base. What's the base?
The x.
Okay. Right.
The number you're multiplying.
And you're going to learn later, but you're not really going to do it until calculus, that any real number can also be the exponent. But any real number can be the base. Okay. So, in other words, 7 squared is just 7 times 7, right? Which is?
49.
49. Very good. Okay, now let's get to where people get really chewed up, as that's with negative bases. So, there's 2 ways to write things. We could do negative 3 cubed, or the opposite of 3 cubed and negative 3 cubed. Notice how I said those. The opposite of 3 cubed and negative 3 cubed. Okay, so these two have different answers, I think. No, actually, these have the same answer. If it's even, then they have different answers. Well, okay. In this case, both of these are negative 27. Right, 3 cubed is 27.
Okay.
On this one, you do the base first, because the base isn't in parentheses. So it would be 3 cubed, and then you put the negative. This one is negative 3 times negative 3 times negative 3, which just happens to be negative 27. Okay? Right? So let me do what I meant to do, and do the part where people struggle, is the even ones. Oh, negative 3 to the fourth. Okay, these have different answers. Okay? And I will tell you, because I'm a nice guy, that 3 to the fourth is 81. Okay?
Mm-hmm.
Alright, so this is the opposite of 3 to the fourth, which is negative 81. This one is negative 3 times negative 3 times negative 3 times negative 3. Now, we did multiplying negatives last time, right? If we have an even number of negatives, the answer is
Positive.
positive. So this is positive 81.
Gotcha.
This
Cool.
really gets people. It really does. It takes a. I can't say
So
that.
basically, if there's no parentheses, it's always going to be negative.
No. Yeah. Yeah.
Okay.
Yeah, you could say that. For now. Like, if it's
For
just
now.
like this.
Yeah.
Okay. But you'll learn later that order of operations, remember we already did that. PEMDAS. Exponent comes first, that's why you do the exponent, and then you do the, right?
Gotcha.
Okay. I do one, you do one.
Okay.
Alright. Everybody loves I do one, you do one. Anybody in the audience wants to do one, I'll find one for you. Okay. These are easy. And there's quite a few of them. So 6, evaluate. That means find the answer. What is 6 squared? Okay, so 6 squared is 6 times 6. And 6 times 6 is 36. Okay, that's mine. Ready for you? Oh wow. Ready for yours?
I'm so ready. Let's go.
You ready?
I'm so ready.
You're gonna hate me in a little bit. All right.
Oh, my Lord.
9 squared.
Okay. 81.
81. Correct. Because
Is that why I'm
9,
going to hate you?
No. 9 times 9, and 9 times 9 is 81. Okay, here we go. This is why you're gonna hate me. All right. We'll get harder. Negative 1 to the fourth power is mine. Okay, so this means I'm going to multiply negative 1 by itself 4 times. And I'll show my work here. Just in the future I won't, but okay. So there's an even number of negatives we're multiplying, so the result is positive. Okay. Alright?
Okay.
You ready for yours?
I'm very ready.
Negative 4 cubed.
Okay.
See, because I gave myself 1 and I gave you 4. That's just how it came up on my worksheet. I
That's okay.
I promise.
It's good practice.
Yeah, it is.
Alright, it's negative 64.
It is negative 64 because we're multiplying negative 4 times itself 3 times. Odd number of negatives means the result is negative, and 4 times 4 times 4 is 64. When I was in like second grade, they made us memorize all the cubes up to like 20 or something. No, maybe 12.
That's
We had to memorize all the squares to 25. Alright, my turn. Okay, negative 1, the opposite, that is red, the opposite of 1 to the fourth. Okay, so I do the exponent first, which is 1, and the negative sign tags on. So the answer is -1. Oh, yeah, you're not going to like me. It's in parentheses, though.
All right.
Key's got her cell phone out using the calculator.
What?
Key's using the calculator on her cell phone.
No, I'm
I'm
not.
just kidding.
I'm still writing it down. All right. So there's going to be positive. So 5 times 5 times 5 times 5 is oh my god.
Oh,
It's 625.
yes, it is. I don't have the answer to yours. I do, but I have to look it up. I have the answer to mine. So, the way I would do this is go, oh, well, from -5 times -5 is 25. So this is 25 too. And then I
Oh
just
yeah,
do
I guess.
25 times 25, which is 625. Okay. Little tricks with exponents. You can do them, you don't have to do them all at once. Okay. So now, moving on. Any questions over exponents?
No.
Very good. Very well. Okay. You want some fun facts about the, the devil's number? You know the devil's number?
66?
666.
Of course I
These
know
are
the
just
devil's
some
number.
fun facts. You can calculate these on your own if you want.
Wait, what?
I'm going to show you some fun facts about the number 666.
Hell yeah.
Okay. $666 is equal to 6. I need to see if I'm on the screen here. Okay. 6. We can calculate these if you want. Plus 6. Plus 6. I need to zoom in. I can't see the exponent. My eyes are growing bad. No. The numbers are too tiny on my screen. Okay, now they're going to be too big, but that's alright. 6 plus 6 plus 6. And yeah, they're too big. Plus 6 cubed plus 6 cubed plus 6 cubed. That's one fun fact. Pretty neat, huh?
Yes.
Don't get all excited. You want me to calculate it for you? Well, 6 cubed is 216. So if you add 6 plus 6 plus 6 plus 6 plus 6 plus 6, you get 36. Right? 6 plus 6 plus 6 plus 6 plus 6 plus 6 is 36. I'm adding the ones
Okay.
section. Carry a 3. 1 plus 1 plus 1 is 3. Plus 3 is 6. And then 2 plus 2 plus 2 is 6. Fun fact, in 2008, there was a town in Reeves, Louisiana that had 666 as an area code, and they finally removed it.
Really?
Yeah.
That's funny.
Okay. This one's funner.
More fun.
More 666. Um, 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed plus 6 cubed plus 5 cubed plus 4 cubed plus 3 cubed plus 2 cubed plus 1 cubed is 666. Okay, so we already know this one, right? That's 216.
Yep.
And these two are 125. And you already know 4 cubed because you did that earlier.
64.
64. 3 cubed is 27.
27.
It's 2 cubed.
12.
Don't say 12. 2 times 2 is 4 times
8.
2 is 8. And then 1 cubed is 1. Okay, what's the easiest way to add all this? Shoot, I don't know. Well, it'd be 216 plus 250, right? There's two. See, like I did, like to underline
Yeah.
stuff when I'm done. And 264s is 128. Yep. And 227s is 54, right?
16.
And
plus
then
2.
this is
18.
54. 54 and 9 is 63, and 9 more is 72.
6.
Did you catch all that? Or did I go
Yeah.
too quick? Okay.
9.
I'm trying to go quick because it's just kind of, showing your work kind of deal.
Yeah, I'm not writing it down.
Okay. Oh, you're not writing fun facts about 666?
No, I'm
Alright,
not.
6 and 10 is 16, carry a 1. 1 and 1 is 2. And 2 and 5 is 7. 7 and 2 is 9. And 9 and 7 is 16, carry a 1. 1 and 2 and 2 and 1 is 6. Okay. You're going to have to review. This is a review for you. What's the first prime number?
3.
First prime number
1.
is 2.
2.
2 squared. Plus the next prime number.
3.
Plus the next prime number.
5. 5.
Plus the next prime number.
7.
Plus the next prime number.
9. Wait,
9 is 3
that's not
times
right.
3.
13.
11.
Oh.
Plus the next prime number.
13.
Plus the next prime number.
15.
15 is 3 times
Oh,
5.
17.
Okay, that is 666.
Oh, jeez.
So, I'll do the easiest. I'll do all of them. This is 4 plus 9 plus 25 plus 49 plus 121. 13 is 169 and 17 squared is 289. Okay, so if we add all that up, we get 666. Okay, but the last one I'm gonna leave. It's real short, so I'll let you do it. Okay. Okay.
Wait, what am I doing?
The last 666.
Oh, God. Okay.
All right. It's real short. 666 is also 1 to the 6th minus 2 to the 6th plus 3 to the 6th, which is crazy. Now, I'll help you do this one. This one's 1.
Wow, gee, thanks.
Oh, come on. 2 times 2 times 2 times 2 times 2 times 2. 2 times 2 times 2 is 8. 2 times 2 times 2 is 8. What's 8 times 8?
64.
64. Plus 3 to the 6th, which is... okay. It's 27 squared, I think, but I could be wrong. Yeah, it is. 3 times 3 times 3, that's 27. And 3 times 3 times 3, that's 27. And 27 times 27 is 529.
Okay, 529.
Very good. So you take 5, which, no, it's not. It's 729. My bad. So if you take one more, you get 730, right?
Mm-hmm.
Minus 64 is 666. Okay, no more fun facts. I'm out.
Perfect.
Well, we do need to move on to the next topic, which is exponents.
All right, before we start, I need a short break.
Okay.
All right, back.
Okay. The next topic is exponents and algebraic expressions. And this is short and sweet. Now, what did we learn about like terms? If I had
You
x
can add
plus,
them together.
can I combine those?
Yeah. Oh wait, no.
No, because they don't have the same variable. They need to have the same exponent too, or you can't combine them. If they have the same exponent, they're like terms, and you combine them just like if it was x plus y, it would be 2x plus y, right?
Yes.
If it's x squared plus x cubed, it would be 2x squared, because 1x squared and 1x squared is 2x squared, plus x cubed. You can't combine like terms with exponents unless they all have the same exponent. Even if there's more than one variable, they all have to have the same exponent. Okay? All right.
Mhm.
It's that time again for I do one, you do one. And
Perfect.
these are easy. Simplify if possible. Okay, mine. 7x cubed plus x cubed. Those are like terms. They have the same variable and the same exponent, so I can combine their coefficients. What's a coefficient?
Coefficient is the number with the expo.
The number in front of the variables. What if there isn't
Yeah.
a number in front of the variables?
Then it's 1.
Then it's 1. Very good. So this is 7 plus 1 x cubed, and 7 plus 1 is 8. Okay?
Mm-hmm.
Oh boy. Okay, here we go. Ready, Key? You can do it. 26x squared minus 27x squared.
Negative 1x squared.
Negative x squared. Very good. Because it's 26 minus 27. You're subtracting. So the bigger number gets the bigger sign, which is negative, because 27 is bigger than this, and 27 minus 26 is 1. And the variable is x squared. Very good. All right, my turn. Sometimes I'm 10x squared plus 8x cubed. Okay, cannot simplify. It is simplified. Okay, why?
Because you cannot combine exponents that
They
are
don't have.
not
They
alike.
don't have the. They're not like terms. Right? That's just simple. They're not like terms. Can't. But you said it right. You're just trying to make it more simple for you to.
Thank you.
Okay, your turn. I hope you can handle it because it's the same. It's the same exponents.
Oh, good.
It's just different coefficients.
Cannot simplify.
Cannot simplify, or it is simplified. You can also write the proper. If it doesn't say if possible, the proper answer to this 5x squared plus 5x cubed is 5x squared plus 5x cubed.
Gotcha.
Because you can still evaluate this for x. Right? Okay. That was the topic on exponents and algebraic expressions. Quick and short. Are you ready for the next topic?
Mm-hmm.
Okay. The next topic is the order of operations. We're going to officially do, I know we already did some, but we're going to officially do it, and I'm going to do it pretty quick because we already know it, right? The only difference
Perfect.
is we really didn't do exponents. We haven't really done exponents yet. So, order of operations. Okay, so again, it's that famous jingle. What's my jingle?
Sloppy.
No, that's
What?
Balzar's Law. What's Balzar's Law? What's the jingle for order operations?
PEMDAS.
Please excuse
Oh yeah,
my
that
dear
jingle.
Aunt Sally. PEMDAS, same thing. Okay. Why are multiply and divide together?
Because you can do either of them.
You do them in order from left to right, whichever one comes first. It's
Right.
multiply or divide. It's not multiply first and then divide. It's multiply or divide. Same goes with add and subtract. Okay, grouping symbols is P, but P stands for parentheses, but it really means all grouping symbols. And we're going to use a lot of these in algebra. So we have parentheses, brackets,
Update.
no, braces, or my favorite, curly braces. We did study this one already. What is that?
Absolutely.
Absolute value. Very good.
Absolute
Or what I worked with a teacher, he used to call this bar over bar. Fraction bar. Okay. So we do all these first. What's inside first? Innermost. So if there's more than one, you do the innermost first. Except
Perfect.
for this one, you do the top first and the bottom first, and then you divide the two. Okay? Since that looks like a division symbol, which it is, it exactly is a division symbol.
Cool.
All right. Next is exponents. We do all the exponents from left to right. I want to do this quickly because we've already done this in a previous lecture. Then we multiply or divide. Okay, so if it's okay, this doesn't mean do 3 times 7 first. When we're doing this, we come across divide first. See, 3 divided by 3 is 1, and 1 times 7 is 7. Okay? Add or subtract. It's not add and subtract. It's add or subtract. Actually, when you get into computer programming, the way a computer handles things, there's a lot of different order operations.
Oh God.
Yeah, they're crazy. That's why I minored in computer science and then gave it up right at the end. I didn't want to. Guy was nuts making us write programs all night. I was like, nah, forget this. I ain't never gonna use this crap. All right, it's our favorite time again. I do one, you do one. Okay, here's mine. Oh, yours is actually easier than mine.
Perfect.
I'm so nice. 20 plus 4 times 3 minus 17. Okay. Now, I know in my head that there's a cheat way to do this and still get the same answer, but being the good teacher I am, I'm not going to do that. Because you can get away with doing 20 minus 17 and then adding that to 12 and getting 15, but I'm not going to do that. Because it gets confusing. I want everybody to use the right order of operations. So, order of operations here says multiply or divide first. Multiplies right here, 4 times 3, which is
12.
12. Now it's all add and subtract. If it's all add or subtract, you could do 20 minus 17 first and then add 12. Because that is called, what was that called? If you add or subtract 3 numbers, you can do them in any order.
Okay.
What was that called, remember?
No, I don't remember.
That was called the associative property. But in this case, we go from left to right. 20 and 12 is 32. 32 minus 17 is 15. Be careful, you can't do this first. You won't get the right answer.
Okay.
It only works for add and subtract. It works in weird ways. If it's 20 minus 17, it's okay. But you can't do this first because 12 minus 17 is negative 5. Oh, yeah, you can. 20 minus 5 is 15. Okay, I guess you can't do it. Oh, my bad.
Oh boy.
Oops, contradict myself here. Okay. Well, yeah, associative property's there for a reason. Here's yours. I'm so nice.
Cool.
Yeah, I know. I'm pretty cool.
Alright, so 6 times 3 is 18, right? Plus 7 is 25.
25 is correct. Because we do the multiply first, we'll have 7 plus 18. And 18 plus 7 is 25. Okay, these are going to get a little harder every time. My turn. 3 times 2 squared. Okay. 3 times 2 squared. Okay, so I do the exponent first because it's the order of operations. And 2 squared is?
4.
4. 3 times 4 is 12. Easy, 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 easy. All right. Are you ready?
Yep.
Okay. I'll say I didn't warn you. You can do it, though.
Boy.
I have all the faith in the world in you, Key.
So do I.
4 times 5 squared minus 4 times 5 squared. That is not 0. Just so you know.
Okay. Alright, so I'm going to do parentheses first. So 20 squared minus 4 times 5 squared. So I'm going to do 20 squared, which is 400. 1,000?
Nope.
40?
It's 20 times 20. So you do the non-numbers first. 2 times 2 is 4. And then you count the zeros. 1, 2.
Oh, yeah, okay. I was right the first time.
Minus 4 times...
Minus 4 times 25.
There you go.
And then 4 times 25 is 100. 400 minus 100 is 300.
When I did it in my head, I got 200 for some reason. Huh. Okay. That's why you don't do it always do it in your head. Good. Very good, Key. Good job. Everybody give Key a round of applause. Oh, nobody's watching. So. Okay. My turn. And I get a little bit more fair on this one. Seven squared. Make sure I'm on the screen up here. I am. Okay. 7 squared minus 48 divided by 4 squared times 5 minus 2. Okay. So, I'm going to go through and do all the exponents first. 7 squared is 49 minus 48 divided by 4 squared. Oh, 4 squared is 16
Same.
times 5 minus 2. It's a whole lot easier if you do it underneath, but we can do that on this one. Okay, so now we go from multiply or divide. There's a divide first right here. So we'll have 49 minus 48 divided by 16, which is
3.
3 times 5 minus 2. And then we do the multiply in the middle there. 49 minus 15 minus 2. And then it's 49 minus 15, which is 34. And 34 minus 2 is 32. Okay?
Mm-hmm.
All right, your turn. 8 squared minus 16 divided by 2 squared times 4 minus 3. Yours is just like mine, except the numbers are different.
Alright, so 64 minus 16 divided by 4 times 4 minus 3. And then 16 divided by 4 is 4. Times 4 is 16, so I have 64 minus 16 minus 3.
I'll give you the first number.
What?
That's the first number of the answer.
Oh.
Okay. 64
What?
is 4 times 64 is 4 times 16. Right?
Mm-hmm.
48 is 3 times 16.
Mm.
So what is this?
48.
Minus 3.
45.
Very good. Okay. Oh, we have more. Oh, we have a lot more.
What?
Yeah, we got 3 more. 4 more.
Is that it then?
Nope. And we got some word problems.
Okay.
And then that will be it after we review. If you want to review. So that,
maybe.
okay, well, that's up to you. Okay. All right, here's mine. 4 times 3 times 6 minus 11 plus 5. Oh, not very nice to Josh here. Okay. All right. So let's start off with the innermost parentheses here. 6 minus 11 is
Minus 5.
negative
-5.
5. Yeah, very good. Plus 5. And then 3 times negative 5 is negative 15. And this is negative 10. Right?
Mm-hmm.
And it's okay if you don't want to write the bracket. You can change the sign and symbol if you want. It don't matter. And then the last number, 4 times 10 is 40. Negative times a positive is a negative. Okay. I think I have room to write yours over here because yours is shorter than mine for some reason.
Okay.
No, it's not. It's the same length. My bad.
Oh,
2 times 5 plus 2 times 9 minus 4. And I'm going to write the answer underneath.
Alright, 9 minus 4 is 5.
Yep.
2 times 5 is 10. 5 plus 10 is 15. 15 times
2 times 15.
30.
30. Very good. Good job. All right. Now we get fun. The next ones are fun. Let's say, yay, fun!
Yay, fun! How was that?
That was very good. Very good. Okay. And I gotta be able to read this here. Okay. Let me make sure. Alright. It's hard to tell the difference between division signs and plus signs. Okay. There we go. 25 plus 5 plus 3 times 4 plus 2 times 7 minus 9 cubed. Okay. All right. Again, I'm going to go ahead and write the answer underneath. So the first 7 minus 9 is negative 2. And you'll notice that everything is the same underneath except I just did the operation, right?
Mm-hmm.
So the next thing would be to cube this, right? 2 cubed is...
Negative 8.
2 cubed is 8, and so negative 2 cubed is negative 8. Okay, now we do... Oh, I put the cube again. We don't need to cube it again. 2 times negative 8 is negative 16. So we can put 4 minus 16 there. Multiply that by 3 plus 5 plus 25. Okay, 4 minus 16 is negative 12. Right?
Mm-hmm.
And now we have, this is negative 3 times 12 is 36. So positive 3 times negative 12 is negative 36. Now it's all add and subtract. 25 and 5 is 30. Minus 36 is negative 6. And they got negative 31 somehow. You know why? Because this is a divide and it's not a plus. But that's okay. I wrote it as a plus. Keep it as a plus. Oh boy. Okay. Are you ready?
Mm-hmm.
All right. I don't know how to zoom on this. It's a PDF and I don't know how to zoom. Oh, there we go. That's much better. Okay. My old body going blind here. 7 plus 3 times 2 cubed minus 1 divided by 21.
Okay. Mm-hmm.
Okay. And just a heads up, the answer is a fraction. I think. Yes, the answer is a fraction. Why they would do that, I don't know. Let me make sure the answer is a fraction. I'm sure I'm reading it right. It is a fraction. Yep. Sorry, Key, you got a fraction.
Alright, so I'm doing the exponent, so 2 cubed is 8, 8 minus 1 is 7. Alright, so then we got 7 plus 3 times 7 divided by 21. So then I'm going to do 3 times 7, which is 21. And so, hold on a minute. Oh, never mind. I dropped a parenthesis where I should not have dropped a parenthesis. Alright, and then 7 plus 21 is 28. So 28 over 21. And then I can simplify that, right?
I don't know. You're doing
What
it.
the heck?
You're doing it.
Alright, so then I'm gonna reduce it to 4 over 3.
Very good. See?
Or 1/3. Correct.
4/3 or 1 1/3. Those are both correct. I'd take either answer. Okay. These next ones are definitely fractions. Okay? I think. I don't know if yours is a fraction yet. I haven't done it in my head yet. But it's probably going to be a fraction. Yes, yours is a fraction too. No, it's not. Yours is. Wait,
Make up your mind.
I'll figure it out. I don't think yours is a fraction, but mine definitely is, because I have the answer to mine, and I don't have the answer to yours. So here we go. 5 times 4 minus 9 plus 10 times 3 divided by 2 cubed minus 1. Okay. So the way to do this is you do the everything. You do the top and you get an answer, and you do the bottom and you get a number, and then you divide the two numbers, right? Right?
Yes.
Okay. So I'm gonna save us some time. I'm not gonna rewrite everything. I'm just gonna find the bottom number is easy. It's 8 minus 1, right? Okay. You see why it's 8 minus 1?
Mm-hmm.
Okay. And then we can rewrite the top. So this is 5 times 4 minus 9, which is negative 5, plus 10 times 3, right?
Mm-hmm.
Okay, which is negative 25, plus 30, which is 10 times 3, over 7. And 30 minus 25 is 5. Okay.
Perfect.
Easy enough? Ready for yours?
Mm-hmm.
Okay. Yours doesn't have any exponents in it, so you can go, yay!
Yay.
Maybe, I don't know. I like exponents. That's a 2, by the way. Can't tell. Okay, there's yours.
Alright. So now the bottom is going to be 10.
Yeah, the bottom is 10. Very good. 7 minus, when you take away negative, you add, so that's 10. I'm going to probably need some more room in that, huh? Okay.
Alright, then I'm going to do 11 times 4, which is 44. Positive. Plus negative 14. So 44 minus 14 is 30 over 10, which is 3.
Very good. Very good. Okay. One more, and then we do word problems.
Sweet.
There's no good way to lecture how to do a word problem. You just do one.
Yeah.
Oh, okay. Now let's see if you remember how to do this. I'm sure you do. Evaluate negative x squared minus 4x when x is equal to negative 5.
Put the paper down just a tad.
Oh, okay. Is that better?
Mm-hmm.
Okay. Yeah, go up there. All right. Yeah. Okay. So, first thing I do is wherever there's an x, I put a negative 5. And now we just evaluate like we just did. In some cases, if you have to simplify, But you can't simplify that, right?
Right.
But if you can, it's easier. It's going to be easier. It'll be less. It'll be more simple. That's why it's called simplify. Okay.
Makes sense.
All right. Negative 5 squared is negative 25. Because negative 5 squared is 25, and then the minus sign sticks. And then negative 4 times negative 5 is 20. Right? With me?
Yep.
Okay. And then negative 25 minus 20 is 5, and the bigger number is negative. Okay. Key's turn.
Yay.
Evaluate. X squared plus 5x when x is 3.
3. All right. So 3 squared plus 5 times 3 is 9 plus 15, which is 25.
Very good. And you're going to learn that we can factor these later to make it even easier.
Ooh,
Make it even
fancy.
easier. Yeah. Because that is... Yeah, we'll do that later. 3 times 8. Yeah, it's 24. Okay, moving on. I need a fresh page for the word problems, so... And like I said, I'm just going to go over examples because that's the way. That's probably the best way to do it. Okay. And there's only one word problem. Ooh, a group project for the whole chapter. Oh, I should send you this. That could be your test.
Boy.
Oh boy is right. Okay, a company manufactures running shoes. Okay, it has weekly fixed costs of $300,000. So every week it spends $300,000, and it costs $30 to manufacture each pair of running shoes. This is actually a real formula. When we get to calculus, you're going to use this a lot. It's called the cost formula.
Okay.
And the average cost would be the cost to produce X amount of shoes. So that means the average cost. And when you see something with a bar over it, it means average, mean. Notice that this is cost. C is cost and X is the bar. So that means I'm going to find the cost to find the shoes, which is 30. So each shoe costs $30, right?
Okay.
So one shoe would be $30. Two shoes is $20, right? Plus the fixed costs like the light bill and the water bill and the electricity and all that is $300,000 a week. To find the average, you would divide it by how many shoes you have. Okay. Real formula. Okay, so find the average cost, which is X bar. Find the average cost for no, it's not. It's C bar. I'm sorry. Average cost is C bar. Find the average cost for manufacturing, and I'm really trying to spell manufacturing, 10,000 shoes a week. Okay? So, these word problems are somewhat simple because we're just going to plug, what are we going to plug in for X?
10,000.
10,000. So it's 30 times 10,000 plus 300,000 divided by 10,000. Okay. So 30 times 10,000 is also 300,000, right?
Mm-hmm.
So 300,000 plus 300,000 gives us what in the numerator?
600,000.
600,000 divided by 10,000, which
I
is.
have a question,
Mm-hmm.
and this might be stupid, but why wouldn't the 10,000s cancel out?
Because there isn't a 10,000 here.
The parenthesis?
Yes. If it's this, then they cancel out. But it's not just that. It's this too. This whole thing is being divided by 10,000.
Oh.
Okay? That's why they don't. You need it. There is a 10,000 here too, because this is 30
Right.
times 10,000, right?
Right, like you could just
Now they
cancel
would all cancel out because the sum has them all. And then look, 30 plus 30 is 60, and you're going to learn why you factor because it makes things a lot easier. Yeah, but
Oh.
so it costs $60 on average to produce 10,000 pairs of shoes. It costs $60. So you know that if you sell them and go buy them, they're going to at least be $60, right?
Right.
Okay. All right. One more.
Yay.
And we'll do it together like we did this one. Okay. A government agency ordered companies that had stored toxic chemicals in a leaking underground container to contribute to a pool of money to clean up waterground supplies. The following model, C is equal to, and I want to make sure that these C's aren't confused because they're different. It's a different problem. C is equal to 200x divided by 100 minus x. Okay, describes the cost in tens of thousands of dollars. So if C is 5, it's $50,000, right?
Mm-hmm.
For removing X% of the contaminants.
Can you move your paper just a little bit?
Like that?
Mm-hmm.
Okay. So to remove 10%, you would plug 10 in for X. And that will give you the cost to remove just 10% of the contaminant. Okay.
Okay.
Find the cost in tens of thousands of dollars. And find the cost. We'll just find the cost for removing 80% of the contaminants. Now, I'm going to ask you a question real quick. Can you remove all the contaminants?
No.
Why?
Because I don't know.
Well, what happens if you put in 100 right here?
You get nothing.
Right.
Oh.
Yeah. Can you divide by nothing? Get rid of all the contaminants. But you can find the cost for removing 80% of the contaminants. Okay, so we're going to plug in 80 for X, right?
Yes.
So it'll be 200 times 80 divided by 100 minus 80. Okay. So, what is 100 minus 80?
20.
20. 2 times 8 is 16, right?
Yep.
And 3 zeros.
16,000.
And 16 divided by 2 is
8.
8. And one of those zeros cancels. And it's tens of thousands of dollars. So how many zeros am I going to add?
100. 4?
4 zeros. So how much money will it cost to remove 80% of the contaminant?
$8 million.
$8 million. Okay. All right. And this should be a dollar sign too. My bad. Okay. That is the end of the first chapter. I think you did very good. Very good. This is the kind of formulas you're going to use in calculus.
Yay.
Heads up. Yeah.
I'm excited.
You're excited? Things you've never thought you'd ever say, right?
Right?
I'm excited about learning calculus.
Especially about math.
Okay. 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 Oh, yes. All right. Let's review. If I have a review, I hope I do. I should. This book should have a review.
Z.
Oh, we didn't do one with fractions, but that's okay. We don't need to. Okay. Okay. All right. In the first section, what is a letter that represents a variety of different numbers?
What?
What is a letter that represents a variety of different numbers?
X?
What is that called?
Variable?
Variable. What is a combination of variables, numbers, and operation symbols?
An algebraic sentence?
An algebraic.
Equation?
Close.
Expression.
Expression. Very good. Keywords for addition are.
Plus, add,
What's the main one?
sum,
Sum. Subtraction.
difference.
Multiplication.
Of?
Nope.
No.
Starts with a P.
Product.
And division.
Quotient.
Very good. Do you want to do examples?
No.
Okay. What is a statement that equates two algebraic expressions?
An equation?
What if I substitute a number for a value of a variable and it produces a true statement? What is the number called?
What?
If I substitute a number into an equation, to the variable of an equation, and the result is a true statement, what is that number called?
Solution?
Solution. How do you tell if a number is a solution to an equation?
I don't know the answer.
Plug it in and see if it's true or not.
Yeah, okay.
Okay. You do know. You just don't know how to say
That
it.
seems like too easy of an answer.
I know. But, yeah, I know. Well, good. See, because that's what teachers love to hear. Okay. How do you convert a mixed number to an improper fraction?
You multiply the first number by the denominator, and then you add the numerator.
Okay, good. How do you do that? How do you do that backwards? How do you convert an improper fraction to a mixed number?
You do the math.
You do the math. You divide two numbers and you get a whole number and a remainder. What's the whole number? The whole number is the whole number, but where's the remainder go?
The remainder goes in the numerator.
And what's the denominator?
The original denominator.
Unless you can do what?
Unless you can simplify.
Reduce. Very good. What's a prime number?
A number that can't be multiplied.
Nope.
Wait. A number that. Oh my god. I know it, I just can't explain it. A number that you can't get from multiplying anything else together.
A number that only has factors of itself and 1.
Gotcha.
What is a number that is greater than 1 that is not prime called?
A number?
No, it's called a specific kind of number. It's not prime. It's the opposite of prime.
Not prime?
Nope. Starts with a C.
Oh my god, why can't I
We'll play
think of...
Hangman.
Yeah, what's the next letter? The coefficient!
Nope. Coefficient's a number in front of a variable.
Oh yeah. What am I answering again? I forgot.
A number that is not prime, that is greater than
Yeah.
1, is called.
Okay.
And there's your C. You already got C.
A. Oh.
Oh.
M. T.
What was it?
T.
T.
What? Why can't I think of this word?
I don't know. Why can't you think of like real letters to play Hangman with? Because they're in there.
S. N.
N?
Yeah.
There's no N.
Is it a composite number?
Composite numbers. Very good.
Oh shit, dude.
Composite numbers. If you multiply two prime numbers, the result is blank.
Coprime?
Nope.
A big number?
Nope. It's on
I
the
don't
screen.
know. Composite?
It's composite because it's not prime, right? If you multiply 3 times 5,
Oh.
you get 15. 15 would be composite because it has
That's a trick
prime
question.
numbers. I know. I'm good at writing tricky questions, let me tell you. Might be doing this for a while. How do we reduce a Oh, if you take a number and you write it as a sentence, multiply sentence of just prime numbers, what is that called? The prime blank. Like this. Like 60 is 2 times 2 times 3 times 5. That is called the blank of 60.
Prime factorization?
Prime factorization, very good. Can you use that to reduce fractions?
Yes.
Very good. How do you multiply fractions?
Straight across?
Straight across. Unless you can
Divide?
reduce. It's better to reduce first, then multiply.
Okay.
For example, 3/4 times 1/9. You get 3 over 36, yes. But that's not reduced. But you can reduce 1/3 right here, right?
Yes.
And that's easier to reduce than this.
So 1 over 12. Cool.
Very good. How do you divide fractions?
You multiply by the reciprocal of the second number.
Very good. When you are asked to divide, you flip the second and multiply.
Yes.
Very good. And then the funnest part, adding and subtracting. If they have the same denominator, what do you do?
Just do the top number, the numerator.
The top number. Yes.
And then the denominator stays the same.
If they're not the same, then you have to find the what?
To find the common denominator.
Not the common denominator, but the blank common denominator.
The lowest common denominator?
Least common denominator. Lowest is correct too.
Yeah,
very good. All right.
Cool.
All right. So you know how to do that.
I do.
That's going to be all this stuff I'm going over will be on the test. Not the vocabulary. You actually doing it will be on the test.
Yeah.
There might be some vocabulary. I don't know. I haven't decided yet. I haven't written a test yet. All right. What are the natural numbers?
1, 2, 3, 4, 5, etc.
What's the difference between the natural number and whole numbers?
Numbers include 0?
The whole numbers include 0, correct. What are the integers?
Integers
The
can be
whole
negative.
numbers and their
negative counterparts.
Which is called?
Their bros.
They attract each other. Plus and minus.
Opposites.
Opposites, very good. What are rational numbers?
Rational numbers are numbers that are fractions.
Very good. Where the numerator and denominator are integers. And the integer cannot, let me talk. The denominator cannot be
negative.
Nope. The denominator can never be. The denominator can be negative.
0.
0. Very good. When I take a rational number and I convert it to a decimal, what are the two types of decimals I get? They either blank or blank. If I take a fraction and I convert it to a decimal, the two types of decimals are blank or blank. They either blank or blank.
Repeat?
Or?
Not repeat?
Well, no. It's not repeat. Well, it is, but...
Or end?
They... I'm Arnold and I am the...
What?
I'm Arnold Schwarzenegger. I'm from the future.
Terminate.
I'm coming to kill you, Sarah Connor. Yes, they terminate. And irrational numbers, when they're in decimal form, they never do what?
What?
Irrational numbers. Never blank or blank.
Never. Numbers.
They never stop and they never repeat.
Yeah.
Okay. What are examples of irrational numbers?
One-third. Oh wait, no, that repeats.
Nope. 1/3.
Oh.
There's two big ones. March 14th.
Oh, pi.
Pi or
0?
Nope.
I guess that
2 words. Blank, blank. Hangman.
Oh God.
Am I on the screen? Yeah.
All right, A.
A.
E. L.
There's no L.
S. M.
Pick the Wheel of Fortune numbers. Letters. Oh, you said M and you said L, I think.
P.
Nope, not P. P is not a free giveaway in Wheel of Fortune.
I don't know what the free giveaways in Wheel of Fortune are.
You are given R, S, T, L, and E. I know.
Oh, R. T.
Oh, there's 2 R's.
Square roots.
Square roots that are not...
I forget what the original question was already. Oh my God.
Okay. What are the 2 types of what are 2 examples of rational numbers? Pi is 1. E is 1. And square roots that are not...
They're not prime?
Nope. Close.
They're not.
Starts with a P. Like, why isn't the square root of 4 irrational?
Because it can...
What's the square root of 4?
2.
2 is a rational number. Non-perfect.
Oh!
Non-perfect square roots.
Got you.
Okay, on the number line. If a number is less than another number, what's the symbol?
Minus.
Does it look like this? Or
Oh.
does it look like this?
The pointy side is on the left.
Left. Less than is left. The opposite of that is,
Greater than.
and if it has a bar underneath it, it means
Greater than or equal to.
very good. The absolute value is the distance between a number and what?
And zero.
And zero. Very good. Our absolute value is the absolute value of a number ever negative?
No.
No, it's always positive. All right. Oh boy.
Oh boy.
Okay. Terms in an algebraic expression. Terms are separated by what two signs?
Equal.
No, that's
Wait.
an equation. And in an expression,
What?
two operations separate terms?
Operations separate.
Yeah, like if I have this, what goes between those?
Plus, minus.
Plus or minus. Very good. That's it. Plus or minus.
Why isn't it the other ones?
Because then that would all be one big term,
Oh.
right? If it's 8x plus 6x, that's two terms. This is, you're going to learn, is 48x squared, but you don't know that yet.
Okay.
Okay, the fact that a plus b is equal to b plus a, what is that called?
Oh god. The distributive? No.
Nope. Go back and forth.
Is it the associative property?
Nope.
No.
It's the other one.
Oh my god, and I can't think of it either.
Your daily trip to work is a commutative property. Very good. If I'm adding, the fact that I can add three numbers or multiply three numbers, and it doesn't matter which ones I multiply first, what is that called? What property is that?
I said that already. Is that the associative property?
Yes. And what is the distributive property? If you multiply something by a sum, what do you do to each add end in the sum? You, like this.
You can distribute the A. You can multiply the A by
Very
B
good.
and C.
Very good. Can you do it with three numbers in the parentheses?
Yes.
How about 7 numbers?
Yes.
How about 190 numbers?
Yes.
Very good. Okay. All right. Addition. What number can I add by and get the same number? What number can I add by?
0.
0. Very good. And my notes are wrong. In this book, it's wrong. It says a plus 0 equals 0. That's not true.
Kind of. I tried.
What is 0 called?
What?
What is 0 called?
The God number?
The blank number of addition. It's called the identity.
Oh.
Okay.
Yeah, I remember.
What is the inverse, the additive inverse of A?
Negative A.
Negative A. Very good. Not to be confused with minus A, which I say a lot in calculus, but I try not to say it in algebra. How do you add two numbers without using a number line? Just basic.
Okay, well, if both numbers are positive or both numbers are negative, you add them together and then just put whatever sign it is in front of it.
Yeah.
Or if they're different, you subtract and then put the sign of whichever number is big.
Very good. I couldn't have said that better myself. All right. When you multiply two numbers, same sign is If you multiply two
Positive.
numbers of the same kind, the result is.
Positive
And
every
if they're
time.
different,
If they're different, it's negative.
and if you multiply a bunch of numbers and the odd numbers are there's an odd number of negatives, what's the result?
Negative.
And even.
Positive.
And it works with divide too, right?
Yes.
What is the identity of multiplication? What number do I multiply? 1. Very good. What's the inverse of A?
Negative. Oh wait.
Multiplicative inverse of A.
That would still be negative A, wouldn't it?
Nope.
Is it A over 1? Is it 1 over A?
It's 1 over A. Very good. Because if you multiply A times 1 over A, you get A over A, which is the identity.
Is 1. Okay.
Double negative is a
Positive.
Very good. Exponents. There's two numbers in an exponent. And we did this today, so I hope you're fresh.
Base.
And
Exponent.
what's the base do?
The base is the number that is being multiplied with itself.
And the exponent is?
How many times you're multiplying it.
Right. All right. Order of operations. What do you do first?
Parentheses.
And? Or?
Exponents.
No.
Wait, what?
Not just parentheses.
Parentheses or any other grouping brackets.
Grouping symbol, brackets. What about fraction bars?
No.
How do you do a fraction bar?
It's divide.
I just divide? If I was to do a fraction bar, it just means
you
you find the numerator, you find the denominator, then you divide. It's like this. The fraction bar, let's say I have this divided by this. Right?
Yeah.
It's just a better way of writing this divided by this.
Yeah.
This is much more easier on the eye than this.
Yeah, right.
Okay. 3x plus 3x squared, can I combine those?
No.
Why not?
Because they do not have the same exponent.
And they're not like terms.
It's not like terms.
Very good. If you said like terms, I'll say, why weren't they like terms? And that is the review. Very good, Key. You ready for the test that I gotta write? I gotta write it still. But I want you to do your homework first.
I will do my homework.
Do you want like a chapter review?
Yeah, throw it at me.
Okay.
Oh. What do you want, Kat?
I'll do that after you get your homework done. And then I'll have
Alright.
Chapter review.
Perfect. I will update you.
Oh, there's a chapter test. Okay, alright. I already know what I'm going to do with the test. And then when you do the test, when you do the test, just take pictures of your work and then send it to me. Like, yeah, because I want it all on a separate page. And the test is, let me see how many questions. 29 questions. You can handle that, right? Key?
Yes, I can.
Okay, I thought you could. I just was making sure. Alright, so we're going to end the stream. This will be on YouTube. I'll probably cut out the break we took. I might not. It's not that long. Hour and 30 minutes is the length that we've been streaming. Appreciate Key. Thanks for your time.
Yes, thank you.
Oh, you're welcome. You're welcome. I hope somebody watches the recording because nobody joined the live streams, but that's okay. I'll get over that. Someday. Alright, I'm headed off. Have a good night.
All right, you too.
Peace.
Bye.